Hi everyone, we are continuing the session in thermodynamics series. So in this session, I will be discussing about the various gas laws, and after finishing this session, we will derive the ideal gas relation and the gas constants, the relation between the specific heats and all. We can discuss only after understanding the different gas laws. So here we are going to discuss about 5 gas laws, starting with Boyle's law. So what is the importance of studying or learning these gas laws and understanding this? So we can demonstrate through the experiments. These scientists like Boyle, Charles, gay-lussac, etc., they wanted to demonstrate the complexities associated with the involved in the measuring properties of gases related to the fundamental properties such as temperature, pressure and volume, like complications in weighing due to the buoyancy of air. Objects will float in air, right? There will be buoyant force acting in the upward direction. So you have studied about buoyancy in fluid mechanics, and problems in pressure measurements over water, and the variation of the gases from ideal behavior. So all these things, in order to study all these things, they have conducted various experiments and they have concluded, arrived at various relations among pressure, volume, or pressure temperature or volume temperature. These are finally available as different laws. So these are the fundamental physical characteristics of the gases which are involved with this in these laws: pressure, temperature, volume, and number of atoms or molecules. Typically, volume is expressed in liters or meter cube in SI system. The pressure in Pascal in SI system or in atmosphere. Temperature, Kelvin. Please note here, Kelvin. If you are writing that unit as such, Kelvin, it should be lowercase letters. Then number of atoms or molecules is usually represented by lowercase n, and the units are moles. Okay, so 1 mole is equal to 6.022 into 10 to the power 23 atoms or molecules. So all these things you have studied in your school classes. Now coming to the first law, Boyle's law is relating pressure and volume. This is Robert Boyle, who is known as father of modern chemistry. He was a scientist from Ireland, and he found through the experiments in his laboratory that pressure and volume are inversely related when the temperature is maintained constant for a gas. All these are gas laws. Okay, these are applicable only for gases, not for any fluid, that is liquid. It is not applicable for liquid, only for gases. So pressure and volume are inversely proportional. P is inversely proportional to volume. Or for a process, we can write P1 V1 equal to P2 V2. For a process between the states 1 and 2, we can write P1 V1 equal to P2 V2. So you know that whenever you apply certain pressure to a container containing a gas, for example, let the initial volume be 1 liter. If you apply a pressure of 1 atmospheric pressure, is like this. If the pressure is applied as 2 atmospheric pressure, what will happen? The pressure is increased. The volume should decrease, inversely proportional, right? So this is the simplest explanation of Boyle's law. When the pressure is increased, volume will decrease, provided the temperature is maintained constant. So this is the case when the pressure is increasing, volume will decrease. So you can get a rectangular hyperbola like this. The curve between pressure and volume at constant temperature, you can get a rectangular hyperbola, which is the case of an isothermal process. We'll discuss those processes in the coming classes. So isothermal process, the temperature is maintained constant. So this is a curve, PV equal to constant. Now the second law is from the experiments of Jacques Alexandre Charles. He was a mathematician, physicist as well as inventor from France. So he found that volume is directly proportional to temperature when the pressure is maintained constant. for a gas. Volume of a gas varies directly with the absolute temperature. Please note that it is absolute temperature. For a process, V1 by T1 is equal to V2 by T2. So this is a case of different temperatures. Here the temperature is 200 and here it is 400 as the volume varies. The pressure is maintained constant. So when you apply more heat onto a vessel containing gas, that means more heat into the system means the temperature will rise. So here the heat addition causes the temperature to arrive at a value of 200 Kelvin, but here more heat is added to the system, thereby the temperature is 400 Kelvin, thereby the volume is increased. Volume is directly proportional to temperature when the pressure is maintained constant. When the pressure is maintained constant. So you will get a linear variation, a straight line between V and T. V on the ordinate and T on the abscissa, you can see a linear variation of temperature. Now the third law is Avogadro's law that states that at constant temperature and pressure, when the temperature as well as pressure, two properties are to be maintained constant, the volume of a gas is directly related to the number of moles, N. V is directly related to N, lowercase n, number of moles. C is the constant of proportionality. And this person, Avogadro, the scientist, he was a physicist from Italy. Or for a process, you can write V1 by N1 is equal to V2 by N2. That is Avogadro's law. So you can see the explanation for Avogadro's law here. When 2 moles of gases is available, the volume is increased. For 1 mole of gas, the volume is 22.4 liters. When you added the gas, that is the quantity of gas is increased. That means the molecules of gas is increased from 1 to 2. The volume is doubled. Doubling the number of molecules means we are pouring more gas into the cylinder, thereby the volume is increased. That is quite obvious, right? Now, next law is gay-lussac law. From Joseph Louis Gay-Lussac, he was an experimentalist from France again. So at constant volume, pressure and absolute temperature, at constant volume, the pressure and absolute temperature are directly related. P and T are directly related, and C here is the constant of proportionality. So pressure and temperature are directly related when the volume is maintained constant in a gas for a process. Next law is Dalton's law. The total pressure, suppose there is a container containing a mixture of gases. For example, you take the case of air. Air contains various gases, right? Nitrogen, oxygen, carbon dioxide, carbon monoxide, hydrogen, many things will be there. So when such a container is there containing different gases, the total pressure in such a container would exert if it were alone in the container. So it is a sum of the pressures of different gases. The total pressure in a container is a sum of pressure of each gas. So you can see the mathematical expression, total pressure is equal to P1 plus P2 plus P3 plus etc. etc. So for each gas, the ideal gas relation should be valid. We will derive that later. So it was from the physicist and chemist John Dalton from England. So this is the explanation. You can see here all these three figures contain the same quantity of different gases. Okay, so here it is 5 liter at 20 degrees Celsius. Again here it is 5 liter. Again it is 5 liter. Now you can see here it is 0.6 mole of hydrogen. Okay, at 2.9 atmospheric pressure. Here it is helium of 1.5 mole. You can see here there is a mixture of hydrogen and helium. Again it is 5 liter. Total it is 5 liter, 0.6 mole of hydrogen and 1.5 mole of helium. Again it is 5 liter only. Total 2.1 mole gas. The pressure, you see the variation in pressure. It is 2.9 plus 7.2, 10.1 atmosphere is the total pressure when the gases are mixed for the same quantity of 5 liter. So that is the Dalton's law. The total pressure in a container is the sum of the pressures of individual gases inside that. Okay, so these are the 5 gas laws which forms the basis for the ideal gas relation, which we will be discussing in the upcoming sessions. So if you have any questions related to this or your valuable feedback for improving the lectures are welcome. You can use the comment section below, and please do subscribe and share and like. Thank you for watching. Have a good day.